Hi guys, in today's video we're going to look at the melting points of metals and non-metals, trends that we see, and finally an exam style question.
How do we distinguish whether we're looking at metals or non-metals in periods 2 and 3? Well, in general, as we move across periods 2 and 3 from left to right, we move from metals to non-metals. If you think back to our video on the periodic table, we described how a step ladder line sits there, and how to the right of it we have non-metals and to the left of it we have metals. Now that general rule again applies. So on the left of our step line in periods 2 and 3 are metals, and on the right tend to be non-metals. We also move from solids to gases. So we know and we can think practically that how the metals over here do indeed exist as solids, and the gases that we have over here, such as nitrogen, oxygen, neon, all will exist as gases. So let's have a look in the trends and the melting points that we observe across periods 2 and 3. Well, between groups 1 and 14, there's a steady increase in the melting point. Now, that's because between groups 1 and 14, we have giant structures. So, for each successive group, if an element has a giant metallic lattice, we have an increase in the nuclear charge, and we also have an increase in the number of electrons in the outer shell, which causes a stronger attraction. So what you can see here is that we have sodium, which has one delocalized electron for every positive ion, and then as we move along through our groups, we have aluminium, which has 3 delocalized electrons per positive ion, which means that which allows for the higher melting point, because as you can see there are more electrons delocalized per positive ion, allowing for stronger forces of attraction. In our giant covalent structures, we also have more electrons present. Each successive group has more electrons with which they can form the covalent bonds, again allowing for this high melting point.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.